Hello, everyone. Uh,
Hello.
Welcome to Uncut Exception Mini Session Episode 12. This mini session, again, is a mini virtual version of our regular monthly meetups of software developers. So, for this session, we will talk about responsive images, which will be shared by Arnelle Balane, and unit testing using Gtest, which will be shared by Ice. So let's start with responsive images by Arnel Barlani.
Okay. Hello everyone. Um, so this evening I'll be sharing about responsive images. I mean how to do our load responsive images in web applications. So in a previous episode, we like shared about like different image formats to like reduce the amount of bytes to like reduce the size of images that we serve in our web pages. Um, but there are also other ways to do it, and that is serving like smaller dimensions for our images depending on their screen size, and that's what I'm referring to with responsive images. So let's take a quick okay, so this is an image served in a web application, and let's take a quick look at its code. So as you see, this is the HTML. This is how you load images in HTML, right? So we have an image and an alternate text, which is good practice to have. And this is our site. So we're loading an image, which is 1000 by 1500 pixels in size, and we're displaying it in our web page like this. So it's fine, it looks nice. Um, its the image is 130 kilobytes, and the thing with this is when we're viewing our images on smaller screen sizes, for example, on a mobile device or a tablet, or even if like desktop but you don't have your screen maximized, and it doesn't really make sense to serve a 1000 pixel wide image when you're only viewing it at, let's say, 250 pixels, right? That's a lot of excess bytes being sent to the browser, and that the user needs to spend like data to download them. And yes, so that's what we will try to address in this session. So how do we serve like appropriately sized images depending on the screen size? And to do that, we need to serve responsive images. So before we touch the code, we need to actually have different versions of the image at different sizes. So our original image is 1000 pixel wide. So I created a version of the image that is only 500 pixels wide, and another one that's only 250 pixels wide. So there are many ways to resize your image. There are like a lot of online tools to do this, and there are also like build tools to do this. For example, there are Webpack plugins to do this, and in my case, I do it using Image Magic. So Image Magic. So Image Magic is a like all around tool for like manipulating images, and specifically I only use one function for Image Magic ever. That's the resize um, operations. So to resize images, you use the convert function with the resize flag and specify the size, the target size that you want. For example, I want 100 pixel wide image. So dash resize to 100, and then you pass in your input image or like your original image, and then the file name of your output image. So let's try that. And here we have our 100 pixel wide image. So that's how I do it if I have to do it manually. but we won't need the 100 pixel image. We already have 250 and 500, so we'll just use those. So now we have our resized images. Let's look at how we load them in our web page. So image tags, they have SRC, which is the image source, but they also support, there's also the SRC set attribute. So the SRC set, this is where you define all your different sizes of your different versions of your image at different sizes. So this is where we put, like, for example, image 1000.jpg, and after the path of the image, you specify the size, like the native, like the original size of this image. So this image is like originally 100 pixels wide, so we specify 1000 W. So instead of specifying pixels, important note, you need to use W. I don't know why. Basically indicates that this image is 1000 pixels wide. So let's just do that. And next one, we specify the next image, which is the 500 pixel image, and we specify its width. And finally, the 250 image, and specify the width. So specifying the width here is important because that's how the browser will know which image is appropriate to display at the given file size. So if the browser thinks, okay, I need to display a 300 pixel image, which one will be better here? So in that case, it will choose 500 because it's slightly above 300. 250 might not be good enough. In this case, we need to keep the SRC, the original SRC attribute. That way, if the browser doesn't support SRC set, it will have a good, like, fallback image. It will just use the 1000 pixel wide image. So in addition to SRC, in addition to SRC set, we also specify the sizes. In our case, since we're just displaying the image at full width, we'll just specify like 100 VW, or like, meaning it takes up the whole width of the screen. So we'll take a look at this later, but let's keep it like this for now. So this is how you load responsive images. Let's take a look at the app. So if I refresh this is like the smallest I can make my window. To see, since we were displaying, we have a narrow, or like we have a narrow like screen. The browser only displays that 250 pixel wide image. That's because it's more than enough to display like a similarly looking like image with the same quality, but definitely smaller sizes at just 14 kilobytes. And as we increase our screen size, so for example, as we reach here, you see that, okay, 250 pixel is not enough here anymore. It will start to see like loss of quality. So the browser will automatically get um, the 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 next quality image, like in the SRC set that we provided. And if we load at a bigger size, for example, it will load the highest quality also that we have provided. So these are responsive images in action. So normally, if you have like users viewing your site on a mobile device, then they would only just see um, your 250 pixel image, and that they just save like more than 100 kilobytes of like data transferred to their browser. So that's nice. Um, yes, that's it. Uh, let's take another look. Okay, so one thing to point out here, you might notice that why did it load like the 500 pixel image when we're only at 200 pixels width, like 200 pixels like width of our screen. Um, my the best answer I have for now, it has something to do with my display. So after checking, not like the official spec, but after checking, my monitor has, I think, around 1.4x like DPI, or like pixel density. I'm not sure of the actual terms, so that's why I have a guess that kind of messes this up. But That's how it works. The browser will choose the appropriate image to display at that um, specific screen size, considering your monitor's like pixel density and everything. So that's so if you have a regular like 1x like monitor here, then it will be more accurate. Okay, let's move on. So this is cool. We have an image that displays at full width and loads the correct resolution based on that width. So that's nice. And let's play more with this sizes attribute a little bit. So let's try a different like layout for our page. So let's say we have a paragraph here. So a custom layout that I added earlier. This is not really important. Let's say our page looks like this. So because a lot of pages, I mean, there are pages that display like full with images. A lot of the images are also like displayed inline in a page, right? For example, in like articles. So images are sometimes displayed like this. And let's as we go down, as we narrow down our screen width, changes layout to full screen. I mean full width. So let's say we have this like site. How do we define? How do we make this image responsive properly? Because at full width, I mean, in this like side-by-side layout, we're not exactly displaying the image at full width, right? So there's no need to display, I mean, there's no need to load the 1000 pixel wide image. The 500 pixel wide would be enough because we're only displaying it at half its original size. So how do we do that? That's where the sizes attribute really becomes very useful. So the sizes attribute also supports list of values. Um, so in this case, we can actually specify media queries in the sizes attribute. So for example, um, in my CSS, I have this like max width media query. So I'm just going to use the same. So at max width 500px, what's the layout? It's full width, so I'm going to use 100 VW, and and then the default value or like the fallback value is half half of the screen size. That's like 50 VW or viewport width. So if we are like at, let's say, what's this, 1000 pixels, then this media query will not match. So the sizes will use 50 VW. So let's see. Again, this is because of my screen. Let's go down to around like, let's say 612. This is above 500. So, oh no. Max width 100 VW 50. Okay, let's go down a little bit more. Oh no. Sizes. Max width 500px and then 50. Yep, this should work. SRC sizes. Okay, cache problems. Did I save it? Okay, I forgot to save it. Let's try again. So here, our 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 screen is, let's say, 540 pixels wide. So it should, if this is full screen, it would normally load the 1000 pixel wide image. But since we specified that by default, the image will only take like half of the screen. So the browser appropriately picked the correct image display, which is the 500 pixel wide image. So that's cool. As we go down here, the image is now displayed like at full width. And then since the original 500 image is not enough, then it will load a higher resolution image. So basically the point here is like the browser will try to, based on the images that we provided, the browser will try to load like the appropriate image, the best quality image, I mean, with the smallest file size, that would be like appropriate to display on the page. So that's cool. So this is basically how the SRC set and the sizes attributes like play together or like work together to serve responsive images. Um, yes, you can specify as many like sizes as you want here and specify as many like media queries as you want. Okay, so this approach to responsive images that we just saw, this is called resolution switching. So, so the definition of that is that you're basically displaying the exact same image, but with just different like resolutions or sizes. So that's resolution switching. And there's actually another approach to responsive images, which is called art direction. So where would that be useful? Art direction and like in contrast to resolution switching is you with art direction you literally use a different image at certain like sizes. For example, here we see a guy singing on stage, but as we go like as we go into like smaller resolutions, you can't really see the guy anymore because there's so much space around him, and then you don't even know, you can't even see his face. So in this case it might be better to like use a different image that's more like zoomed into the guy or like into the singer, so that it still gives more like context to what the image is about. So here I prepared like a separate image which is more zoomed into the guy, so you don't see this guy playing the guitar anymore. We can even make it like it's only showing his face, so you can do things like that. But that's all up. That all depends on your site. So how do we switch between different images depending on the files, on the screen size, or how do we do art direction with responsive images? We do use, oops, we use the picture element. So we've seen the picture element before. It's usually used with using, this is what we usually use when we want to use different types of images. For example, if you want to use WebP or AVIF or JPEG, depending on which one's supported, we use the picture element, and we can also use it for art direction. So for the picture element, we just put our image here. This is the same image. Everything, if you can still specify the SRC set or the sizes attributes if you want. So in our case, we still want these responsive images, so we'll just keep that. But to add another, like to display these cropped images, we can add an extra source element. So the source element accepts this basically the same attributes as the IMG element. So let's specify SRC set. In our case, we'll use the cropped images. So cropped 500.jpg, which is 500 wide, cropped 250.jpg, which is 250 wide, and sizes. In our case, since this is at 500 pixels already, it's displayed at 100%, so 100 VW. And like the key thing to do art direction here is the media attribute. And this is basically a media query that needs to match in order for this image to be displayed. So in that case, we will use like max width 500px. So at 500px or less, like viewport widths, it will display this cropped image. Otherwise, it will display like the original full stage image in our case. So let's see if this works. We still need to, so with picture element, we always need to provide an image fallback also. For browsers that don't support picture element, then they will just fall back to the IMG tag, which is supported everywhere. So let's see if this works. Let's try with like full width first. So, oh no, what happened? Picture source IMG. Did I add a margin? So anyway, let's just keep it like that. So as we go down, oh no, Yeah, good question. Why is that weird? Mhm. I think I think my HTML might be messed up. Let me just fix. But I think it's correct also. Okay, let's just try. What's wrong with this? Picture, source, sizes, img, sizes, picture, p. Okay, let's just try. So as we go down, as you see, like as we reach this, as we reach below like 500 pixels, the image has switched to the more like cropped in version so that you can see the singer more at lower resolutions. So that is art direction. So basically, those are the two things with responsive images. First is resolution switching, which might be like more popular. You're basically displaying the exact same image with different resolutions. And then the second one is art direction, which is you display like a completely different image when you are in certain like um, screen resolutions. You can use both of them as we just saw here. We're using SRC set with picture element, so that's cool. And yeah, so that's it. Basically, just want to share like an extra tool. I don't really use this a lot, but it's helpful for when you don't know, when you can't decide, for example, like which widths of the images should I use. In my case here, I just divide it by two. And I mean, I just have it from 1,500 to 250. There are like other ways to do this. So there's a tool from, I think this is from Cloudinary. It's called responsive breakpoints, where you just upload your original image and then it will suggest which like width image width should you use. So if you want to use it, it's available. And with that, I think that's it for me about responsive images. If you have any questions. Faye, you're on mute.
Sorry again. So yeah, time for questions. Any questions, guys? I have a little question though.
Yes.
So like if once the resolution changes, the browser will download again the image, right? The other image appropriate
If
for it.
yes, if it needs to. Yep.
Ah, all right. Okay,
So
that's it.
for example, as you go from 500 pixels to 1000 pixels, if the browser keeps using the 500 pixel image, it will look like pixelated. So the browser will download like the higher resolution image and then just switch it once it's downloaded. So you still get a sharp image at higher resolutions.
Okay. So by that point, there are two images downloaded in the browser, right?
Yes, the first one is the 500 and the second one is the 1000. But in like for most users, you don't really like keep resizing your dev tools, right? Not everyone in the world are developers. So for normal users, that you usually just keep your screen at a certain size, so you don't really see that um, repeated downloads a lot unless you're a developer who keeps messing up with your dev tools and like screen sizes. So it works. It definitely has benefits, especially for mobile devices.
Okay, that's it for me. Thank you, guys. Any other questions? No. So I
No.
guess we will proceed to the
Yes.
next speaker.
Thanks.
So thank you, Kuya Arnelle. So the next speaker will be Ice Quizon, and he will share about unit testing using Gtest. So here's the screen, Ice.
So, hello. My name is Ice, and we will be talking about, or I will be talking about Gtest and how to use it when you want to do unit testing on your C++ application. So to start with the presentation, I have created here a uh, a simple program. So what this simple program does is that it's basically just like a um, an inventory system, just a simple command line inventory system, or it's not really an inventory system. It's like very dumbed down inventory system. So I'll just show you what it does. So here, so what you see here is that there's the add command, delete, show list, customer by, stock up, and then the exit. So when you do an add, let's say add item one, add item two, add item three, and you go and show list, it will show you the list of it will show you the list of items that was added. So um, that will be the application on which we will be creating our unit tests. So just a quick rundown through the code. So if we go to the code, there is main.cpp, operations.cpp. Although I think that's already I did not use that in this instance. There is cli.cpp, shop.cpp, state machine, and then utils. So let's open the code one by one. So let's go to main. So here we see it's just basically create a shop instance and then uh, run a setup, and then run the shop and then do the cleanup. So if you're wondering what these functions look like, so you go here in shop.cpp. So here you see um, here you can see the setup, which is basically it sets the state machine. Um, and then here you can also see the shop, the run, which basically is this is the while loop that runs the whole application. I think in this instance I forgot to make, which explains why uh, commands are still going is still popping after. Yeah, this is what I would want to see. Anyways, moving on. Um, and then here we have a cleanup. So I didn't add anything since I basically it just says program exiting, so it's just there. So it ensures that you use the exit command, and anyways, so if you're wondering what the uh, each file looks like, we can go and see the each file. So here we have the public functions, private functions, etc., etc. So it has a state machine, it has the CLI, which is the command line interface, and so on and so forth. It also has the inventory. So this is where most of our items go. The state machine here is where it just manages the state of the program. So by state, you can go here. What I mean by state is that it depends on what command. So add, delete, show list, customer by, stock up, and exit. So there's that. This is what the state machine looks like. And then we go to the CLI. So this is also what the CLI looks like. So here is where you add your menu items. So if ever I wanted to add a menu, let's say test, and then let's just say there's add a state test, then we then basically it's going to be added to the menu. So what so going back here, so we also have this utils.cpp. No, wrong. Here, utils.cpp. So here we can see some of the utility functions that I use throughout the application, like get in, tokenize a string, etc., etc. So it's just here. This is just the two of the utility functions that I just created. So it's not really it's just a simple program. It's not really well built, I guess. I haven't really given much thought to the whole architecture of this program. So it's just a simple program. So here we go to the tests. So since this is a Gtest presentation, so might as well see what the test would look like. So when first let's first run a test. Let's first run a test. So the tests are located here in the build tests, and here CPP test. So you just execute that test. You will see uh, all the tests that are being run. So you might wonder where in the code this is located. So this is obviously in the test folder. So test, you might think it's in main, but it's not. This is where you initialize the Google test, um, the Google the Google test framework, and then you create a run all tests. So this run all test searches for all of the Google tests that is being that can be found within the executable. So if we were to look at the CMake of this CMake files um, of this executable, if I'm not mistaken, that was CPP test. So if it checks for all the tests, all the Gtest, the Google tests being defined here in test.cpp, test util, and then here you can see there's the main. So this is obviously where you can find the initialization of the framework. So let's go to test.cpp. So it's just so that we can see what a dummy test would look like. So here you see that there is this is how you define a test in Gtest. So you just write test, and then the test. This is like the test category, I guess. I would like to think this is the category, and then this is the test name, should pass. So if we were to create another test, okay, and let's just say this should still pass. Let's just say expect equal to is to 2, and then from here we make this the entire program again. You should see it's added here, so it should still pass. So here dummy, and then I've also created this tokenized string. So yeah, that's how a way to categorize your test. So let's go to the dummy. So for the dummy, I mean for the what was the other test? Tokenized string. Let's go to util, test utils, I guess. It's in test util. This is what it looks like. So basically a test tokenized string, once the name of the test, and then this is the what the test would look like. So this is just basically a simple test. So to see how tokenized string is being implemented, let's just check with utils. So here you can see if you give it test, it returns test. So it should still return here. Yeah. So you might be wondering what this expect underscore equal means. So it just means it's a macro that is defined in the Gtest that checks if this value here is equal to the value here. So there are a lot of macros that Gtest uses. So one of the many macros that you can use when you're, let's say, asserting or expecting um, some values is assert. So here we can see we can use assert equal. So you might be wondering what what's the difference between assert and expect. So basically, what it means is that when you say assert, assert means uh, any if both of these values are not equal, it would automatically terminate the test. So to give you an example, we can say assert equal to. We can make this. Let's see if the test still runs. So here failed. So as you can see, it displays failure here. Expected 2, which is 2, to be equal with size, return size 1. So it failed. So what happened there is that it did not go through with this expectation or this checking. So if we were to revert it to expect equal, what would happen here is that um, uh, the test would still fail here, but it would still continue on checking this part. So just so that we can see it continues, we can add um, a log here. Let's just see that it continues. So here you can see it continues. So if we were to make this into an assert, um, hmm, one assert, it did not continue. So you can see the the C out that we did here did not appear here. So what does it mean when when do you want to use assert versus expect? So you want to use assert if ever um, you come to a point in the test where you don't want the test to continue, since um, basically it will fail even more if it continues. So for example here, if return size is um, not equal to 2, then might as well not check if the values here are correct, since you already know that um, the string should return one string. So let's just make this one, and then let's make this test 2. So this would still fail. This would still fail, but it would make sense since you don't need to check the other tests, the other expectations here, the other assertions. Uh, so going back here, so you can chain these expectations. You can chain them. So let's say this one. Let's just say test 1, test 2. So this would still pass, just to let you know that it passed. So there you can see. So this is what uh, you will see when you run your executable for the test. You see a global test environment setup, the number of tests from dummy, the number of tests from tokenized string, and then number of tests overall. There. So also it also has this MS, which helps with when you want to check the performance of your test, if it's fast or not. So um, what other things can we try? Okay, we can also try this. Um, there's also another macro where you can just say expect true. Um, so when you say true, there's also a macro that says expect false. Obviously, um, yeah. So if we make that, oh yeah, we cannot see that. So let's just make this fail there. It checks for Boolean values. So yeah, there. Um, and then what are the others? So there's also um, GT, LT, which basically means greater than, and this is less than. So it has two values. So you can say one is greater than, let's say, 0, and less one is less than 2. So this would pass. Yeah, it still passes. So if we were to invert the order, this would now fail. Yeah. Just so that you can see what the error message would look like. So expect actual 0 versus 2. So something like that. And then what else? There's also expect not equal. So if there's expect equal, so expect not equal, not equal. So you can run it here. It's still passed. So since both of these are not equal, yeah. So that's what most. This is the basic expectations that you can do when you want to check if um, two values are the same, or you want to expect certain function that returns true or false. So let's go now to the different kinds of tests. So as you can see here, this is using test. So there are three kinds of test macros that you can use when using Gtest. So these are um, let me just copy this. Um, Let me just copy this function test. So there's test F. There's also test P. So what it means is that um, you use test F. You use test F, this test F macro, when what you're trying to test is inside a test class. What I mean by test class, I'll show you an example of what a test class would look like. I think it's shop. Yeah, this is. So this is another way that you can set up your tests. So here you can see I am using test F. So it has the test shop, and this is the name of the test. So this is another way that you can initialize your tests or make your tests. So here you can have a setup here. I just said do setup, and then here you can also do the teardown of the tests. So it inherits from test, which is coming from Gtest, testing test. So you might see that I just used test here, but that's because it's inside the namespace testing. Since test is inside, basically it's testing test this inside this namespace testing. I just placed the entire test inside the namespace, so just so that I don't need to write the testing here. Anyways, so there's that. And you can also add additional functions here if you want. So for example, you want the setup to do something like set up nodes, and then what else? Let's say you want to set up inventory and the like. So you can just add it here, and oops, sorry. So you can just add it here, and um, they're all set. You can modify, you can add code here and the such, just so that it will be nicely put together in one class, all the functions that you're using. Since if you were to go back to test utils, no, that's not it. It's kind of messy. All just test, test, test. Here we can see that there's a proper setup, proper teardown of each tests. So what happens here when you do the test F is that it starts by calling the setup here. Well, first and foremost, it starts with um, the test shop constructor, since you need to create the constructor first. You need to create the test object first, and then so on and so forth. So, and then it calls setup. So you don't need to call setup anymore here. No more something like this. So you don't need to call the setup anymore here. And then there's also teardown here. So you don't also need to call teardown here anymore, which is good, which is great. Um, so another thing, so this is how you do, you do the tests. So another test that you can create is test P. So what test P is, basically it means test with parameters. So if I were to give an example, let's just, excuse me, let's say we want to replicate this test. Let's create a test P, and then um, let's see. Since when you want to create a test sample, um, what you want to do, oh, I'm sorry. You just put it in the bottom. What it is that what you want it to do is it accepts a parameter, and based on the parameter you create lots of test cases. So you just create one base test case. So let's just say something here. So this is, let's just call this counting. Let's just call this counting. So what it does is that um, let's let's say you want you call the instantiate test case P, and then what you do with it is that you add your test case name here. Let's say test shop, and then you create the name of the test. So test shop counting, and then you add here testing values. And since we are already inside the namespace of testing, we just don't need to write the testing anymore, just values. So you just say 1, 2, 3, 4, 5, and it will create test cases for um, it will create test cases for using counting, this one. So okay, yeah, yep. So let's just undo all this stuff for now. Yeah, let's just this one here, like that, and then we go back here. So the next thing that we want to see is that I want to show you guys is here in cd source gtest sample. You can use dash dash help. Oh, I mean, not this. No, 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 not the sample, the cpp test, right? So you run this. There's you can see here a lot of commands that you can use. So gtest test list, gtest filter, also run disabled test, gtest repeat. You can repeat the number of tests. So for example, you want to make sure um, the unit test runs 4 times, just so that uh, you're ensuring yourself that it doesn't break anytime soon. Um, gtest shuffle, gtest random seed, so you can shuffle it or like specify random seed, so on and so forth. So just just so you can see, you can just test here. Oh, here. So cpp test has dummy, should pass, should still pass, tokenized string, all that stuff. So if you want to just run a single test inside there, so you just say dummy dot should pass, and it just runs the single test. So you can also use regex, so dummy dot star. It runs all the tests in dummy. You can just specify star, but I don't know why you would do that, since you can just technically write cpp test, so just runs everything, so on and so forth. So you can see, so let's go back to the program. So what I want to show to you guys is how to when you have when you already have like this program and you want to test. So assuming you don't do TDD, so if you do TDD, you do the test first and then the implementation. So something along those lines. But let's just say you forgot the test, some sort, or you want to test an already existing code. So you go here. So let's go here. So let's test. Let's test shop. Let's test shop. Oh. So what we want to do is here. Let's go. Let's see what the test shop we see once here. So let's just say we want to test set state machines. No, I mean setup. Since set when you want to test this function, you need to have a getter function, since state machine is private. So let's just skip that for now. Let's just go with setup. Since in setup, what is already in setup, it calls set add callback, set lead callback, show list callback, and so forth. So we want to test setup. Okay. So what we want to do now is we go to test shop, since I've already created a function for it, file for it. So this is what we want to use. So let's just go to let's just first modify the CMake file, just so that this gets built. So there, so there, and yeah, shop that test shop. So here. So what we want to do is that we want to test shop setup. Since what we want to see, what we want to test is the shop setup. So what we need to have first is we need to have a shop object. So this is shop s. So yeah, something like that. Since shop doesn't have a constructor, so let's just construct it immediately during this. So let's first add. Let's ignore this for now. Let's ignore that for now. So let's add shop.reach. So let's try to make this. First, let's redo this since we do everything. Let's try to run it. Okay, there's an error. Okay, there's an error. This error is with tokenized string should okay, so there's test util tokenized string redefinition of class. It happens in Gtest. Okay, there's a redefinition of class that's happening. Hmm? What? Okay, so let's just go to CMake. It's probably just a simple CMake modification. Um, hmm, test shop main test shop. Okay. Hmm. Hmm. Where was your definition of class? Okay. This is in test util. Let's check test util. That's because there's another. Yeah, I forgot to delete this. I'm sorry. Yeah. Let's just delete everything here. Delete two. And let's just make it again. So there. So we have a. We'll go here. There's test shop. So here you can see there's already test shop. When you run test shop setup doesn't do anything, obviously, since we didn't add anything. So we just add expect true. So if just for sanity's sake, let's just test if it still works. Yeah, it fails. Yeah, that's correct. Good. So what we want to do is that let's go to shop. I want to see what shop does. Person. Okay. So what shop does is that it it accesses the state machine and calls set add callback. So what we want to do is that we call shop s and just call setup, right? And what this does is that it runs the setup. Yeah. So let's just do that first. Let's just do that first. Is private within this context. Yeah, let's not add it in private. Let's add it in public. Ah, since okay, there's an error. Undefined reference to shop setup. Okay, yeah, that's because we didn't add in the CMake the um, the common file for the shop.cpp. So let's just add that there. Here. No, let's just enter this. Delete. And then let's just change this to shop. Make that again. There's another error. So it just means that I need to add almost all of the CPP files just so that we can see. Let's just put here. So what we want to do is we add shop, state machine, just add everything. CLI. Yeah, utils. That's it, I guess. That's everything. There. So when you run it, you can still run. So let's go back here to shop, test shop. So now we have a problem. What's that problem? Well, technically this test doesn't really test anything. It just runs setup, right? So what we want to do is that we want to know if the functions inside the function setup is being called. So how do we do that? Well, what we want to use is that we want to use mocks. So I've already created a mock here, mock state machine. So this is where gmock comes in. So there is a mock. Let's just go to mock state machine. So just exit this just so that we can see clearly. So this is what a mock object in Gtest would look like. So you can see here some of the macros. So mock method one, the name of the function, and then the function type uh, along with its parameters. So it's basically just a copy paste of shop.h. So if you go to shop.h, you can see here set state. I mean state machine. Sorry. Yeah. So here we have set state, set args, do current state, exit. So what would happen if, let's say, we will not implement this? Well, let's just implement it first, and let's see what will happen if we do that. So what would happen is that no such file or directory. Yeah, that would probably happen. So we go to cmake test cmake files. Yeah, and let's include that here. It's in, I believe, test. So let's clear this up first. Run cmake again. Make. So what would happen here is it would show an error. What is this error, you ask? So is this? It's a very long error. TLDR. Don't want to read it. So I already know what this method would this error is from. So basically, what should be done when you create a mock is, let's go back to mock, is here, this part. We want to supply to the mock machine, to the mock object, an interface. And when we go to state machine is not an interface. It's a class. It's not an abstract class. What we want to do is we want to make state machine an abstract class. So to do that, let's first let's make this as an interface. So I just copy that. Let's go back here. Let's call this I'm sorry, I state machine. Let's make all of these functions here virtual void virtual, and at the end we want to add some zeros. So what we can do is we just say equals 0, and then let's just say equals 0. Release this. Go here. Then that do that 7 times, I guess. Yep. And then let's just delete this for now, since we can add it. No, I think it's okay there. Yeah, I think it's okay there. And then for the state machine, let's just remove this part. No. Let's just use this. Yeah. So what happens now is that we go back to the mock state machine, and we just say I want to inherit from I state machine. And when you want to make a mock object, okay, this is going to be a lot of errors. Okay. A lot of errors. Namespace errors. Um, yeah, there's a lot of errors just from that change we did here. So let's go back to state machine. I think what we need to do is, I think we need to override this. I think it's okay. Hmm. What is that? What is the error here? Let's first do this first. Oh, no, 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 no. Let's first um, make sure that what I'm doing is correct. Okay, there is an error somewhere. Ah, okay. Probably something wrong with. No, there's nothing wrong. It seems to be the issue. Semicolon, I guess. Hmm. Oh, but we can. Let's just isolate the issue first. Here. Yep, it's still there. Ah, probably because here. Yep, yep. Okay, okay. I see, I see. Yep, I did not close that properly. Yep, just a semicolon. Okay. Hmm. Okay. Ah, okay. In mock machine. So yeah, we need a semicolon here. Yeah. So there's here still errors everywhere. Error, error. Declaration, function, boolean, itong time function marker, declaration task testing, function marker. Mm, hmm. Let's see. It seems to be the error here. Hmm. I've already made it into a virtual function. So this shouldn't, there shouldn't be a problem, I guess. Well, let's first deal with one mock method. Let's see what would happen. Okay, we're getting somewhere. Oh, let's first remove this. So just you can see what mock method is causing the error. Not that. Ah, okay. This is here. This is a const mock method, right? So um, with no, it's not a type. Const. What? Let me check. Const. I think it's mock const. It's not const mock. So mock. Uh, like that's why it's yeah. Okay, so here we go. Yep, it's already there. So it's running. So we go to app.cpp first. Since this is a state machine, what we want to do is let's just make that an I state machine. Go to no, and then what we want to do is we go to state machine.h, go to state machine. Oh, no, not in state shop. Go here. We make that into a state machine. What we want to set it, right? And yeah, what that's the error because follow are pure within I state machine. Yeah. So it's looking for a um it's looking for some of the functions here. So what we want to do is here, I guess what we want to do is we can just say this is a state machine. No, cannot convert from correct, right. I keep forgetting. Since I state machine, this should public. Um, right. Okay, cannot allocate object abstract type. Ah, okay. This is starting to become um, a bit, a bit complicated, but that's okay. What we can do is instead of here, let's just say we just make this a unique pointer first. No, shared unique, and then of a state machine. And then we copy this. We go to each, we come here, we go, this is in shop, each, I mean shop.cpp. Delete this here. No, that one. And then, hey, another error, lots of errors. Right, I need to add that here. Oh, I'm sorry. If unique pointer is in memory, and current types are right. Come here, we'll make this a make ptr of a state machine, and yep, this is better, much better. So basically what we want to do is we find all the machine that has a dot. Could be better, but okay. Machine dot. Really? Anyways, let's just find all the state machine, and let's just replace all of this with an arrow. Do that, and something like that, and convert and update. Yeah, I think, yeah, we need to go to the CLI. This is a lot of work. Let's see if we can just bypass all of this. Nah. Nah. Let's go to state. Yeah. Yeah. Nope. Let's go here. And then we go to set state machine. Something like that. Okay. We just come here. Yeah, I'm really sorry that this is taking so long. Anyways, hopefully I'm still here. Um, yeah, I don't know here. Oh, then we go to CLI.h. Go to convert date. Let's make this into an I, and then go to .cpp. Yeah, this is gonna be a lot of problem. This is gonna introduce a lot of problems. Yep. Um, yeah, since you can't do that with a now I'm thinking that this is a bad using doing it like this is a bad idea. Well, I think this there's a better way. Let's just do um, the easy way. Let's just make this into a state machine. Um, we go to state machine of each. Let's just remove this entire class. Delete. Nope. E. And then what we want to do here is let's just do that. And then when you go to the mock instead of here, we'll just do that. Yeah. Go to shop.h. Remove last. It's probably still gonna work. Here. Ah, nope. Yeah, this one, that one. So yeah, shop.cpp. Here. Okay. Here, shop has not been declared. Okay. Okay. Inventory state machine was not declared. Ah, right. Shop.cpp. Let's just remove this. And then declare the scope. What other errors is there? Shop has not been declared. Shop.cpp. Ah, I deleted the include. Ah, right. State machine. Ah, yes. Let's just dot g. Okay. What is this error? Include. Ah, what? What's that? Okay. Yeah. There. Yeah. Let's go here. Run test shop. Okay. Test shop. And you go here. What we want to do right now is in the shop.h, we want to set the state machine with a mock state machine. So what is the mock state machine that we have? It's here. So what we want to do is let's just say auto uh, mock sm is a mock state machine. And then we want to set the state machine to the mock state machine. That makes sense. Is implicitly deleted because of this condition. Maybe ill informed. Hmm. I think this needs to be. Let's just make this into a pointer. Of a machine. And then something like that. Image shared. What's that? Oh, right. Uh, Wait a sec. Let me just check. Yeah. That error. Oh, right. Just gonna be like that. Yeah. So let's run test shop. So here you can see that's running, and the state machine has been sent. So what we can do here is we can send the mock state machine. Define reference to end collector. Testing expectations. Okay. I think this is a CMake problem. Ooh. Do I need to add Gmock here? I don't think so. There seems to be an error with my Gmock. Assert function Gmock. Okay. Let me first check. Gmock. Um, okay. There seems to be an error with my Gtest library. Anyways, let's proceed with what I need to do with the mock test shop. So what we need to do here is we want mock sm dot expect call. So what is this expect call? This expect call is a macro wherein you supply the function and the function parameter of the function parameters being passed to the mock object. So if we go back to where state, no, shop.cpp. Here we can see um, there is a set add callback here. It's being called. So what we can do here is we can expect to call here. We can expect that mock sm, the function of the function set add callback of mock sm is being called, and we add here. This is just a wildcard, and um, we can also specify here the number of times being called. So let's just say once, or this also works once. So something like this, and you need to call this one, two, three times. So 3p, and let's just call the functions here. So what this does is that mock when you call setup, when you call shop setup, the mock object functions is being called. So set add callback is being called, set delete callback is being called, set show list callback is being called, and set stuck up callback is being called. Here you can specify the argument being passed. So since this is a function parameter, I will not bother to check if that's correct function. Although you can, I'm pretty sure you can do something about that just to check. And then you can also, what you can also do here is there's also an option for mock objects wherein you specify the order in which they are being called. I think it's in sequence, yeah. So you can add here in sequence, and basically here also, if you want to ensure that the functions being called by your mock object is in sequence. Yeah. So this is what as your standard uh, s- Gmock uh, Gtest test would look like. So this is the function being test, and this is basically this is the setup. This is the setup. Let's just place it here. Setup, and here are your checking. Um, yeah. So this is what a standard Gtest test would look like. So if I think that's all. I'm really sorry that I couldn't make it. I can show to you what this would look like since there seems to be a problem with my Gmock. And I think debugging this would take a lot of time. But I guess that's it. Yes.
Nice. That's like too much information.
Very. I'm really sorry. I I wasn't able to test the Gmock. All these undefined references being spit out when I make the executable.
Yeah, that's fine. I think you were able to share like the testing with Gtest itself. So that's That's great for me. Questions.
Questions?
I
No,
have a question. I have a
sige.
question. So like
Okay.
in Python, like the unit test, you we can patch like a specific method of a class. Like for example, if you have a class, um, I don't know, music, and it has a method like get length, and it
Mm-hmm.
returns the length of the music. In
Mm-hmm.
your test, so for example, in your test, you don't necessarily have a file, right? So you can just map
Mm-hmm.
the get length method to always return a specific value, for example, 10 or 20,
Mm-hmm.
whatever. So is that also possible in Gtest without like actually over creating a mock of the class? Like as you said displayed a while ago, you created a mock of extending from an interface of the original class, right?
Mm-hmm.
That seems like a lot of work for just writing one method. Is the same scheme possible for in Gtest? I mean,
Well, hmm. Well, I'm not sure if it's possible, to be honest, since when I was using Gtest, what we always did was we always created a mock object whenever we wanted to simulate something outside of the class. Um, yeah, we always created a mock object, and based on that mock object, we specified the return types. Yeah, I also forgot to show to you guys the how the mock object returns something if ever the function returns something. Yeah, you can check it in the documentation of Google Test if you want. Yeah, but yeah, so far when I was working with Gtest, we had to make a mock object. So yeah,
uh,
I hope that answers your question.
yeah, yeah. I just have like a follow up question to that. So follow up question
Okay.
is like, what if you have a class and then one of the class makes an external API request, so you don't normally want to run that external API request during
Mm-hmm.
while running test. So
Mm-hmm.
what's the typical approach in Gtest for these kinds of for these kinds of classes? Like as I mentioned, in Python, you can just patch that specific function, so you actually are still operating with the class, except that
Mm-hmm.
that one function is still is mapped. In Gtest, do you have to write a different test case, for example, but this time using the mock object instead of the original class, or to test the method or something?
Yeah, I think for API calls, what we usually do is that um, um, we usually create we usually create a mock object for those classes that uses an API call. So um, just so that we want to separate the part of the code that we can control versus the part of the code that basically relies on the API. So most of the time for API calls, we just place it in one separate file, as one separate class or separate. Usually separate it. But what you can also do, um, and this is like this is I don't know if it's the proper way to do it, but this is what we usually do. If there's something that we need to test, we what we usually do is that we create another class, and then what we usually do is we add if def macros, if that makes sense. If def macros in the file, and basically we check if what we are compiling currently is for a test. So if it's for a test, we use a separate class for it where we can simulate where we can simulate the API calls, etc. And if it's for the real thing, we can use third party libraries to do the API calls for us. So yeah, there's all that option also.
Okay, very interesting. Thank you.
Hi, I have a question also.
Yes, yes, Ryan.
um,
So yeah, so
okay, it's one.
for
That's not what I'm going to ask, but please answer it
uh,
also.
okay, okay. So for the difference between assert and expect. So for assert, what usually happens is that um when you do an assert, um you're basically saying if this part of the checking fails, we do not want to continue with the test since it would be pointless to check for the other values of the test. For example, wrong length. Let's say if you want to check for the list, let's say a list returns something. Um, you want to check for the length first, right? So like, um, so if at the beginning the length is already um, not correct, then we can just exit the code. We can just exit the test and go to another test. But for expect, what usually happens is that um, when you expect something and then it doesn't happen, it is still considered a failure. But the test case still continues on to the next expectation calls. So usually, what you want, it usually happens when you want to test for a list. So maybe there's just one part of the list that's wrong, and then it would be a waste if like you're already halfway through and then there's something wrong. So might as well just note it that this is an error. Let's see if the next values of the list are still correct. So it would be also helpful. So yes, that's the yes, I yeah, that's the difference between assert and expect. So your other question?
Yes, thank you. That's clear. Other question is not sure if this is like a good question or something because I'm not very familiar with C++. Because if I that like for web,
Mm-hmm.
for example, um, there are some testing frameworks that are well suited for certain kinds of testing.
Mm-hmm.
For example, if you're just testing like pure JavaScript functions, you might go with frame testing like libraries or frameworks that are only like lightweight, they only run JS functions,
Mm-hmm.
for example. And if you do like test for like DOM elements, you have to test like the page being rendered.
Mm-hmm.
You also would go for like other testing frameworks that are like well suited for those. So my question would
Mm-hmm.
be like, is Gtest like something you would use for like any kinds of C++ project, or is it like specific for certain kinds of C++ projects? I don't even know if there are kinds of C++ projects, but
So
yeah,
for Gtest, what I would recommend is that use Gtest only for unit testing. So you want to test functions, functionality. You can also use it for module testing, like how if this module calls for another module and so on and so forth. But if you want like an end-to-end testing, that would be you would probably use another um, test framework for it. Back when I was in my previous company, we had like about like we had we had three testing methodologies. So there was a G test, and then we had a framework of our own, and then we also had PyTest. So what there's also another part for PyTest. So um, for a certain project, you can use Gtest, but it doesn't mean that Gtest is you should only use Gtest exclusively for a single project and no other test framework. So you can mix and match other test frameworks and see what other test frameworks fits your needs. So with C++, there's also Qt. If you're familiar with Qt, it's like the web, not the web, the user graphical user interface framework for C++. And I believe there's also a testing framework wherein you can also test for the graphical user interface. There's also another test framework that also caters to unit testing. That's I guess it's Boost testing. using the Boost libraries. So yeah, there are a lot of test frameworks out there for C++, and I think it depends on the project as to what kind of test framework you want to use.
Nice.
All right. Any other questions, guys?
I'm good. Thank
And I
you.
think there's no question in the live stream. So I think let's wrap up. That's it. So yay. We talked about C in this session, like in something related to C. It's not just
Plus
web.
plus.
So I guess that's for this session. Thank you for coming, guys, and thank you for sharing, eyes. Yay! We have a new recruit. So yeah, for these mini sessions, like we're just dragging whomever we want, whoever we can convince, not we want, whomever we can convince to join us. So if you have anything to share, any project or something new to learn, don't be shy to ping Kuya Arnel or any one of us, and we can talk about it here. So balik-balik, guys. Anyways, bye.
Thanks, everyone.
Please like and subscribe.
Bye.